Hello everyone, so very good morning. So we'll wait one more minute. We'll start then. Okay, yes, we'll start now. So let me share my screen. Okay. So in previous sessions, what we have done, so we saw that, so how to work with a so task, right? So here in a task, we saw that, so how to work with a dependency, parent and child task, and at the same time, so how we can able to so schedule the task automatically, how we can able to resume, how we can able to suspend. So before that, what we have done, we discussed about the time travel option. So based on retention period, right? Time travel, what you can able to do. So you can able to go back to 1 month before, or you can able to go back to 5 days before, whatever it may be, and then you can check exactly at that particular period of time. So how the table looks like, right? It is kind of, so we can say that snapshot at that time how the table looks like, right? That's it. But you cannot able to see so what all the transactions performed on the table. It means suppose we have a EMP table. So let's assume that, for example, we have created EMP table. On first day, we have inserted 100 records. 100 records. So just observe carefully. So we need to know the difference between the time travel, and then we need to know the difference between streams auction. So in this session we are going to discuss about streams, or we will call it as a CDC, capture data change, capture data change, or streams. So what is the purpose of streams, we will understand now. So first day, let's say this come to the example. First day we have EMP table, and so first, so we have inserted 100 records. On second day, 20 records updated, and on third day, okay, so you can 10 records again, 10 records inserted. On fourth, so 5 records deleted. Now observe this. So what is happening on the table? So every day, so we are doing some transaction, and then we are performing on this particular table. In the time travel, what you can do, you can go back to this, and then you can able to check, so before this, so how the table looks like, right? So before this, so in 10 records inserted, before these 5 records inserted, how the table look like, you can able to check in a time travel. At the same time, so here, so we can able to see, just a minute. I'm sorry for that. Okay. So now, so what we can do here, so in a time travel, we can able to go back and then check. So any specific day, so timestamp. It means so what is there at that particular time. So how many records, and then so what is the records, how the table looks like at that particular time. We can able to check it in a time travel. But here, so what we required is now in the final table, after all these transactions, you can able to see that in a final table, right? And so we need to understand what all the transactions performed on this particular table. Okay, so let's assume that. So for example, so your time travel is like a bank balance. You can go back and then you can check at any specific day. So for example, today you can able to see your bank balance, right? Total available balance. Maybe 1 month before, what is your total available balance? You can go back and then you can check, right? So and then you can go back and then you can check 10 days before what is exactly your available balance. But you want to know along with that, so till today, what all the transactions performed on your account. You need to know the history. It means here on this particular table, when how many records has been inserted, how many records has been updated, how many records are deleted. I want to see those information for this particular table. Then streams will come into the picture, or we will call it as a change data capture, or we are going to call it as a stream. So stream is a object. What it will do is, when you created a stream on this particular table, for example, this is your source table, right? So let's say this is our so table. On this table, we are performing a stream. We will create another stream table, another stream object. We cannot say it is a table. It is a object. Once you create a stream object, what will happen is, whatever the transactions you are performing on this particular table, it may be DML, all the DML operations. It can be insert, update, or delete. It will be captured in your stream object. It will be captured in your stream object. And so by comparing the stream object, you can able to check how many records is inserting, how many records is updating. And one more thing. So when you create, for example, let's assume that stream. So for this employee, we have a stream object. This is a stream object. This will record all the transactions, whatever we are performing on this particular table. This particular table, we are doing a transactions, right? All the transactions will be available on this so particular table. So just a minute. Okay. So now, so when we are doing that, okay, so you can able to see that. So each and every transaction, okay, until you consume, until you consume the stream table. So once you consume the stream, so then only, so stream will reset. It means, so once you consume means whatever the transaction it has captured, everything will be reset. Consuming means utilizing the stream, utilizing stream. So that is now we'll call it as a consume. Consuming means whatever the data is available here, so we are picking into another so table. So once it is consumed, so most of the time, so just treat it as a target table, for example. So if you want to so update the details, okay, let's assume that. So we'll have a consume table. Once it is consumed, so the stream will be empty. Stream will be empty. Again, it will reset from that particular time and date. Particular time and date. So now this example again we will discuss. So when you are working with so slowly changing dimension. So slowly changing dimension implemented, we will see like a small so project kind of implementation in the end of the session. So again, we will come to so with this example. So what exactly we are going to do it in a stream. So just remember, by utilizing a stream and then by utilizing so our capture data change, we can able to implement ESCDs, slowly changing dimensions. Slowly changing dimension concept we can able to implement by using a stream options. We will see that exactly So how we can able to do that practically. But now we need to understand what exactly the stream is, what it will contain in a stream object. And then when you consume, what will happen? When you don't consume, then what will happen? So just observe this. So now, so we have a table. So we will create a stream object for this particular table. When you create a stream object, what will happen? It will record all the DML operations, what we are performing on this particular table, on this particular table. And so if you don't consume it, if you don't consume it, it will keep on adding the records here. It will keep on adding the transactions. Once it is consumed, then so your stream will be empty. Again, it will start from that particular time. When the time we have consumed, right? Even one record also, if you consume, so always it is going to reset your stream object. Now, so let's observe how we are going to create a stream object, and then so what all the transaction we can perform there, we will see that. Now come to the streams, change data capture. So now let's see, so how we will insert the data. So first, let's create a table. Now just we are creating a table here. Now we are in, let's connect to our class and then public. Observe this, we are creating a table, employee underscore st, right? So, and then column name, employee ID, and then data type. So salary, manager ID, employee ID, three columns we are creating. And the table name is employee underscore st. We are utilizing for the stream, that's why I have given st. So now, so let's create a table. Now we created a table. Now the table is available here. So table is available. Okay, we don't have any records. Now, if you want to capture the changes on this particular table, what you need to do? We need to create a stream, right? All the DML operations will be recorded in a stream object. Now, if you want to do that, so let's create a stream object for that. Now observe this. Create a replace stream. This is a stream name. On table, see this one, on table employee underscore, this is the table name, right? We are telling that in this command we are creating or replace stream. So this is the stream name, on table, this is the table name. See this one, for this particular table we are creating a stream. Now we created a stream here. See this one, stream successfully created. Now if you check, for example, show streams, observe one thing here. So it will tell you, so for which table you have created a stream. And then observe that what it is telling, that delta changes. Delta changes, right? And then, so what is the table name? So which table you have created a stream, right? So now let's come here and just check what is available. So this is the table structure, right? Observe the table structure, ID, salary, manager ID, right? Now observe the structure of the stream. See this? So let's start from, this is stream, right? This is employee underscore stream. This is a stream object. Now when you observe this, so say this one, what you have along with ID, salary, manager ID, you have three more extra things. That is metadata action, metadata update, and then metadata row ID. This is a unique row ID. It will be generated if any record inserted. The metadata action, it will tell you insert. If any record deleted, metadata action column, it will capture it as a insert, it as a delete record or insert record. If anything updated, so it is going to give you the details in metadata update column as a update. Metadata update column as a update. And now, so we have a stream. This is related to the stream. This is related to the data table, right? Now, so what this stream will do, it will capture the changes for this particular table, whatever we are performing, right? So if you want to see that, so let's insert some records into the stream table. So now let's observe this. We are trying to insert some records into the stream table. Let's come here now. So this is the table name, and then we are trying to insert some records, right? When you are inserting some records, now observe this. How many records created? 6 records, right? So when you inserted, so we have around 6 records is available here. Okay. So when you have the 6 records, now when you check the table, okay, just a minute. Observe carefully. This is the table details. This is related to the table, right? Now observe how the data looks like in the table. How the data looks like in the table. If you observe employee ID, salary, manager ID, right? So these are the 3 columns. You can able to see that in this particular table, right? Now observe how the data is available in a stream. See this one. When you observe that, see this, what you can able to see for each and every record what we have inserted into our table, it is capturing metadata action as insert. See this one, what it is telling, metadata action is insert, right? Metadata action is insert. Okay, so now, so let's observe. Okay, so this is a metadata action insert. So this is for the inserted records, right? Okay, suppose if I again insert or if I again delete, so it will have a transaction here. So until you consume this particular stream, until you consume this particular stream. Consuming means, for example, you have all the details here in this stream. For example, inserted details, deleted details, and then updated details. Let's assume that all the deleted details I want to so load into some other table. These are the deleted details from this particular table, or these are the updated details from this particular table. So whatever the transactions it is performing on your, so this particular table, right? So we need to so separately maintain the transaction to just to check the things. Okay, I will tell you one scenario. So when, so it can be, these streams can be utilized, and then when these streams can be updated, so we can use in real time. For example, let's say, let's consider, so when you booked a order in Amazon, so let's assume that you have booked 5 orders, okay, on your ID. So you will have a 5 products it has been booked. So then they will insert it right into one table. After that, so maybe 2 products delivered, so 5 products delivered, you have returned 2 more products. What they have to do, they have to delete, they have to update that transaction, right? For your name in the table, they have to update. So only 3 is the final products. 2 products you have returned. Then what they have to do, they have to keep that as a separate track, right? So for that, what you will do, whatever the transactions you are performing on this, here you are updating. So here you have updated. So instead of 5, you have updated to 3. Then that whatever you have updated, those details, they need to keep it as a separate track to understand how many products has been returned, right? From each and every customer or from this particular product, right? So they have to capture. For that, what they have to do, they need a separate table. Let's assume that that is a consume table. Let's assume that is a consume table. Then, so once it is consumed the data from the stream will be always, it will be reset. Always it will reset. And one more thing, on one table, on one table, you can create n number of streams. There is no limit. You can create, here we have created only one stream, right? So one stream here we have created for this particular table. Like this, you can create like 2 to 3 streams based on requirement. For example, all the inserted records I need to so send it to another table. All the updated records for this table I need to send it to the another table. All the deleted records I need to send it to the another table. In that case, then what you have to do, you can create a 3 streams. Okay, again, so we will discuss this particular topic again when you are implementing SCD. Okay, so now, So just concentrate on this, how the streams will work here. Okay. So if you are not understanding, don't worry about that. So again, we will discuss. So one more time with the real example. So now,
Dinesh,
yeah.
this is Priya here. I have a quick question. What is the practical use of the stream, and when is that you want to use it and then clear the stream? When do you use it in real time?
So to capture the changes in versioning, that's what I am telling. So so for example, if you ordered something from Amazon, so if they want to check, so whatever the products has been updated. So for example, you will order some orders, right? So maybe some you will, once it is delivered to you, maybe you will return some so products, right? 5 products if you ordered, you are going to return some 2 products. If they want to like capture all these transactions, whatever you are so performing on the any particular table, then you can able to see that in a streams data. So if you observe what happened here, you can able to see the only inserted records, right? Okay, let me so complete for delete and update also, then you can able to understand. So how exactly we can utilize the stream here. Now what you can see here, we can see only inserted records, right? So whatever the data available in the table, this is the table data. Now observe this, this is the table data, right? And so when you have the table data, but what you have in a stream, but in a stream, you can able to see this one, it is telling these records are inserted, right? To understand what is happening on your table, so the stream will be helpful. For example, this is only insert we have done. We will see that for deleted and then updated. These records, if you see the data in this table, final table, this is a final table data after insert, after update, after delete. But what all the transactions you have performed on this table, like how many inserted, how many deleted, how many updated, those details you will never know, right? Those details will be available in a stream. Okay, is it clear? Priya? We will see that with the example now.
Okay.
Okay. So now, so let's observe this here. So here we have inserted. Now what we discussed, until you consume, until you consume, the data will be still available in a stream. Now if you observe in the stream, you can able to see the data, right? So now let's consume the data and then just observe what will be, so what is happening in the particular stream object. Now let's come here. So here we will create another consume table. So this is a consume table. It means so we are creating another consume table, or we can consider that as a target table, anything. So here also we required so these columns. Now we have another table. Employee underscore consume. So we have another table. Okay. Now let's insert some records. Now, so we are not directly inserting from this particular employee underscore st table. So what we required is we need only inserted records into this table, recently inserted records or updated records. Then what we can do is you can utilize the consume so table. We can so load it in the consume table by using a stream data. Now, so to consume that, insert into, you can observe this, insert into this is a table, consume table, from where we are selecting. See this one, select employee ID, salary, ID from employee underscore stream. We are taking the data from the stream object into this particular table, right? Now observe this, when you are consuming, what is going to be happen here? Now 6 records inserted, right? So when you check the table, so this table you will have a 6 records. So let me refresh it here. You can able to see 6 records in the consume table. It has been consumed. 6 records we have, right? Now check the data in the stream table. Observe the stream object, not the stream table. Stream object. Now observe what you have? Stream is reset, right? Once it is consumed, stream will be reset. See this one, stream is resetted now. It is not. So again, when you are doing some other transactions, for example, again let me insert three more records here. Just we are trying to insert three records. Observe this, three records inserted. If you check the stream, again it will capture. Again you can able to see three record details here, insert, 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 right? Okay, so this is fine. Now, for example, if you update something, if you updated something for this, your, this is your table, right? If you update some records here, or if I delete some records for this particular table, what it will happen? Again, it will capture the changes in a stream, right? So let's delete some records from here. Delete. Now observe this. Delete from. This is the table, right? Table where. So what is the columns we have? Salary we have. Salary equal to. So let's check. So we have this one. What we are doing? We are deleting. So when I am deleting, see this one. Two records. How many records deleted? Two records deleted. Now when you check your table, so here two times, first time we inserted, second time we inserted three more records, first time we inserted six records, second time we inserted three more records, total nine records. After that we have deleted two records, right? Totally you can able to see seven records. Now just observe this, seven records, right? So now on this is your original table. On this table, you have two times we have inserted, and then so one time we have deleted. So now second time, so whatever we have inserted and then we have deleted, whatever the transactions we performed on this table, if you want to see that, let's come to the stream. Now observe the stream here. What you can able to see this one. Two records inserted, one deleted, right? One deleted. So it is telling that clearly this particular record deleted from the table. These two records inserted into the table, right? This is a recent stream. Until you consume, these details will be available in a stream. Consume means nothing but you are loading the data from this stream to other table. So let's say only deleted records I required. So from this particular table, what all the records has been deleted, then we can load these deleted records into another table, right? So then we can able to consume. For example, say this for the same consume table, what we will do is where if you want to load only this particular delete record, metadata action, we will take the complete thing. This column name will take, let me copy, metadata action equal to delete. It means delete a record, right? Metadata action equal to delete, right? So what it means by this is a deleted record, right? If you observe here, see this one, deleted record. It means we are consuming only one record from a stream. Observe this carefully. So this is one of the certification question. If you consume only one record or one entry from a stream, what happens to the stream object? Is it going to remove all the records? Is it going to refresh everything, the table, or is it going to so keep remaining inserted or updated records, or is it going to keep all the records? So what will happen is it is going to reset your stream. It means that completely once it is consumed, even one record also if you consume from the stream table, automatically, so the completely the table, so it will be refreshed. The complete object will be refreshed. Now observe this, what is happening here. So here we are picking only one record, right? We are trying to insert So we will do that. So that is a create statement. It is insert into this consume table. So select, so these records from, so stream table where metadata action equal to delete. That particular deleted record only we are consuming. We are inserting into this particular table from a stream. Only one record, right? Now observe this. Only one record we have consumed. Now observe the stream object now. Observe the stream object. See this one, it's reset, right? That's why when you are working with these streams, so you will create a multiple streams on a same table. So you will create, if you want to capture the inserted records, for inserted you will create a separate stream. You will create for updated separate stream, for deleted record separate stream. And one more thing, if you observe, so this is for insert and updates, you saw that. So how the data will be available, right? How the data will be entered. But when it is coming to update, for every updated record, you will have two entries in your stream object. One is insert entry, another one is delete entry. Delete entry. For update, you will have two entries. One will be insert entry, another one will be delete entry. Why we have two entries for the update means, so in your partitions we are going to discuss this. So just so remember this, Snowflake, it will store the data in blob storage file format. When it is storing, so in normal update will happen here, will not happen here. For every update, it will remove the previous file and then it will going to insert the new file in that place. Always it will remove the previous file and then it is going to insert the new file in the place if you have, even you are doing update. That's why, so for every transaction when you are performing here, for every, so especially when it is update, it will, you can able to see one delete operation, one insert operation. The previous record will be deleted and the new record will be updated. So let's say, for example, update. So let's update the table. This is the table, right? Update table set. For example, we will take salary. Let me check the data in this stream table. This is the data. 7 records we have. So for example, let's take 20,000. So we have around 20,000 here. Here. Now how many records we have for that? Only, okay, 2 records we have. Let's take any one record which is having. We have only, so 60,000 with only one record, right? Let's take this. Just observe this, what we are doing. We are updating your main table. This is our main table. So we are updating salary. So wherever salary is, this one. So when we are updating, okay, updated. How many records updated? One record updated. Now observe the stream here. One record only updated. Now observe the stream object, what it contains. See this one. Previous, what is the value? See the one entry will be delete entry. Another entry is insert entry. See this one, insert, delete, insert, delete. Now what happened? Previous old record deleted, this 60,000 record deleted. In place of this, so you have a new record updated, new record, sorry, inserted. See this, you can able to see the employee ID same, manager ID same, only the salary has been updated here. Sorry. For remember, for every update, you will have two entries. One is insert entry, another one is update entry. Okay, fine. Sorry, one is insert entry, one other one is update entry. Suppose if you delete, so here we have insert and delete is there, but how to identify whether this record is a deleted record or whether this record is a updated record or whether this record is a inserted record. Here also insert and delete is there. Now just observe this. So here let's delete some record, so 50,000 let's take from the table. One record deleted, right? And let me update, let me insert one more record here. Now I am inserting one more record. See this, inserting into the table. One more record we are inserting. Now one record inserted. What we have done? One record we inserted, one record we have updated. And so one record, so this one is updated, this one is a deleted, and then this one is a inserted. All three operations we have done. Now how to differentiate? Now observe this in the stream object. When you come to this, see this one, what you observed, see this, so multiple insert, so deletes. So now how you will identify whether this record is a updated record or not? If you want to see that, see this one, metadata update, this column, metadata update column. If you see metadata update equal to true, metadata update equal to true, and then metadata, so action, metadata action equal to insert, then you can consider that as a updated one, updated column. So you see this one, for insert, this is a false. For delete, the updated column is a false. Only for these two things, see this one, so these are the true. This is a old record, this is delete, right? And then if you want to pick only the updated record, so from this particular thing, or you want to pick so only the old record. So after the update, you can able to see the details here. In this is your original table, you can able to see the details, right? See this one, you can able to see the details. This we have updated, right? So recently we have deleted. After the update, this is the details. Before update, what is the value here? If you want to capture that also, then where you will get that? You will get that option in a stream object. Now if you go to the stream, and then you can able to see the details here. See this one, you can able to see the details. So you can consider the previous value I want before the update, you can take this value, right? Metadata action equal to, so delete, and then metadata action equal to update. These details, so only the previous value details I want to capture into some other table, then you can consume only based on metadata action equal to delete, metadata action equal to update equal to true, right? So this is the, so one thing. And one more thing, okay, so everything it is capturing, right? Okay, any DML changes, it can be insert, it can be update, or it can be a delete. But so one thing, so we need to remember here, so for every, so whatever the queries we are running here, every time when you are running, if you observe, so anywhere I didn't use commit, right? I didn't use commit. Commit means nothing but saving. Commit means nothing but save option. For example, when you do something in your Word document, you will save the document, right? Control S. The same way here in a databases, in other databases, so you will have a commit option. Commit means whatever the transaction you are performing, it is going to save. But here, Snowflake is auto commit. Snowflake is auto commit. No need to give the commit so intentionally. So when you perform something, it will be auto committed. If you don't want to do auto commit, I don't want to implement auto commit, so I want to cross check the things what I have done later. So once it is confirmed, then only I have to do a commit. Then so what will happen is, what we have to do is, we have to implement begin, and then after done commit, you need to implement a commit. within the begin and commit, whatever the transactions you are performing, it will not be committed automatically. So let's say here we have these records, right? Okay, so now I will execute the begin. See this one, begin. I will execute begin here. Now begin statement executed. It means so it will not be auto commit. After this, whatever we are performing, it will not be auto commit. Let's say, so I will insert again these many records into the table. This one, we are trying to insert these many records into the same table. When I try to insert, and one more thing, so when it is not committed, your stream table will not capture because it is not committed, right? It is not updated. So now observe this, we have inserted records, right? Now when you observe, so this particular thing, so st, see this one, still how many records you can see? Only the 7, right? Only 7 records you can able to see, right? Because it is not committed. So here it is showing only 7. So but here, so it is, so that in because of, so it is not committed. And if you observe the stream data, now observe the stream data, stream, see this one. Can you able to see those inserted records details here? No, right? We cannot see any inserted record details here. Inserted record details here because it is not committed. So whatever the transaction you have performed, so this you have performed within the begin, inside the begin. After the begin you have performed. So you can delete anything. For example, let's see, you can delete from table, where, for example, let's take manager ID. Manager ID equal to 911. Okay. Now observe this. I am deleting, right? Insert, delete, whatever it may be. So now I have deleted, right? Still, if I refresh it here, and then if I check, see this one, still 7 only, still 7 only. So, and then at the same time, if you check it in a stream, this delete entry should be there, and then insert entry should be there. See this one, still we have only 4, right? Those details, it is not updated in a stream. Now observe this carefully. Once it is committed, observe this, what we are doing, we are including commit. Now we are implementing commit. So here begin transaction, here commit transaction. So now when you committed, so it means nothing but transaction is committed. Begin means transaction is beginning. So it means it is telling that this command is telling to Snowflake, don't commit anything until I tell, right? That is the meaning of this. I am beginning the transaction, don't commit anything until I use commit statement. Here you are telling that commit the transactions, the whatever the transactions you have performed, so commit the transactions, it means save the transaction. So now observe this, we are committing, done, right? Committed successfully, statement successful. Now let's refresh it here. Now you can check the data here. See this one, now it's updated, right? 11 records, it's updated. Now check the data in the stream. Now observe this in the stream. See this one, now it's updated, right? All the inserted records, all the deleted records, you can able to see it here. But in this, how you will identify whether this record is an updated record or not? Based on metadata update. If it is true, if it is there, then we can consider that particular record as a updated record. Okay, so this is about the stream, how we can able to so work with the stream. And remember, on one table you can create multiple streams. There is no limit, there is no limit to create a streams. Only one thing is, when you consume a stream, even one record also, the stream will reset. Always it will reset. That we need to remember. Always it is going to reset the stream once it is consumed, once you consumed. that we need to remember that. The same concept we will see that. So when we are implementing slowly changing dimension versioning concept. Okay. So any questions in the same scripts, I will send it to you. So each and everything, so you can able to so see
So
that.
Ganesh, while
So you
creating a
can practice.
stream, can we
Mm,
filter saying this stream should have only
mm,
inserts and this stream should have only updates?
mm. So when you are consuming, we can able to do that.
Not while creating a stream.
Not while creating.
Okay, by default, everything will
You
be
need to-
captured.
but yes, exactly.
And this table will not be shown on your left list saying,
No,
stream
no, it
table
will
is.
not. This one, this is just a object. See this one.
Oh,
So what is the string we have created? You cannot able to see. So only views, materialize views, and then tables, we can able to see it here. So if you want to see that, for example, we created a stages also, right? So, and then we created a tasks also. Those things also not available here. If you want to see that, those information will be available in information
sure.
schema, this one,
Okay.
information schema. And if you want to see that, just we have to use show option. For example,
Can you show me this stream that you created in information schema?
we have to use show streams. Sorry. Just use the show streams. You can able to get it here.
In the information
everything
schema, can you show me the
So in information schema, let me check here. Stream details, we have a stage details here. So everything will be stored. Schemas we have. The pipe details, packages. This is just a kind of view. So where it will be available information only. So but where exactly, so I have to check. So I will check once exactly where it will be available. Okay. But if you want to see any stages what we have created, what are the file formats we have created for everything, so we'll use show streams or show stages. This one, these are the stages. And then if you want to see the tasks, show tasks. So like this we will use. But these things will not be available. So in our table list, in our public list. Okay.
These streams will occupy storage thing, I mean computation and cost.
Mm.
So,
No, so it will not occupy anything.
mhm. So it will not charge anything for streams.
It will not charge anything.
Mhm. So when we'll capture the data, I mean, when we'll consume the data like in real time, how frequently we'll do that?
Okay. So so frequency means it depends. So let's say for example, so any customer address changed, right? We need to
Mhm.
capture the customer previous address and current address also. So whenever, so let's assume that salary has been changed for the any employee, we need to capture the previous hike and then current hike also. It depends on the, so how the data is changing. So based on that, we are going to consume the stream.
Mhm.
Okay. Any other questions?
so the same retention period also applies for the stream?
No, the retention period will not be applied for the stream. So that is only for our tables.
So if I didn't
So
use
by
a stream
default,
for 1 year,
mm,
so still the table will grow, it will be there.
so the details will be available in the stream.
Okay.
So if we are not consuming data in the streams, so
Mm-hmm.
how many days it will be in the table? I mean stream.
Okay. So that will be 14 days. It will be in a stream.
Okay.
14 days. So that 14 days, you can remember. So one thing, the whatever the details available in the history, this is for the 14 days. Another thing is, so whatever the files we are keeping in a stage files, right? That is also 14 days. By default, it will be available. And then, so whatever the stream we are creating, right? This
Yes.
streams details also, if you don't consume, then that will be available 14 days. So these 14 days is the like the benchmark here. So for the Snowflake.
Mhm.
So what is the purpose of having an approach like this, where you have a stream, and then when you consume, the data will be deleted. When you don't, it'll be there
Mm.
for 14 days. What is the intent
Mm.
behind this kind of thing?
Intent behind this is, for example, if you don't, so once it is consumed means nothing but utilized, right? So once it is utilized, so why again we require the same data in the table? It's unnecessarily, so it is like increasing the storage, right? That's why once it is consumed, it will be resetted from the backend from the stream table. Anyway, the data is available, so you are so picking the data into some other location, some other table, right? So that's why, so it is going to implement. Okay, so
So, you are speaking about SCD, right? Let's take an SCD
mm,
example, okay? For example, in a real world, what we do is from an ERP system or some transactional system, we'll bring all the data into the stage table, right? And then
mm,
from the stage table, we'll put it into a dimension table. We'll do an SCD and we'll put it into a dimension table. uh, After we load the into dimension table, the stage table will be completely deleted, like or whatever.
mhm,
Every day it will be deleted, right? So that we are not storing the data in a stage table. How is
mhm,
this? I mean, where does this fit into the scheme of things? Like, having it in the stream and then uh, removing
mm,
it away from the stream. Let's say there's a product log or something, right? You're based on usage. You are
mm,
having some information. So what is the
correct.
first step? Like, you will get all the logs into your mainstream table and
Mhm.
then you will consume it.
Okay, I'm telling that. I will give you with the example, then you can understand this particular thing. Okay. So now just observe this. When it is coming to SCD, what we are going to do, we are going to capture the changes, right? It can be a versioning, or it can be a flag, or it can be a date range. Correct, right? So if you so understand the SCD properly. Now, so what you will do, you will have a source table. If you observe here, you will have a source table, and at the same time, you will have a target table, right? Let's assume that, so whenever we have data in this particular source table, so the changes is happening on the source, only the inserted records you need to be the new records. Inserted means nothing but a new records. New records need to be come to the target table one. Okay. And so whenever you have any update on the new existing record, you need to load it into another table. Okay. Whenever you have any delete, the deleted from the so existing record, then it has to come to the target table 3. So let's consider this scenario in this particular situation. So how you are going to check, so whatever the transactions you are performing on the source table, you need a log, right? Like which record has been inserted, which record has been deleted, which record has been updated. Then what you will do, so for this particular target one, you are going to create stream, especially for insert. You will create on a same source table, you will create 3 streams. Now observe this, another stream. This is, so you are utilizing for delete. So another stream again you will use. So this particular stream, you are this far, you will utilize it one only for the update. Whenever you have update, so then, so whenever you are doing the changes, all the changes will be captured in all the streams, right? When you are consuming, so once it is consumed to the target table, means nothing but inserted records from the stream, it captured, and then it has uploaded into the another table. So this is a, let's assume that this is a transaction we are identifying. So deleted records we can identify here, updated records, so we need to maintain a history. So all the updated records, so you will get it from a stream. So why you are creating 3 streams here? Once it is consumed, then everything will be flush and fill kind of thing, right? If you created 3 streams, whenever you have done the changes in the source, automatically these streams will be updated. So if you want the target table 1 inserted records, then you can use the stream. So another person maybe, so they want only the deleted record or updated record, they can use this stream. So once they use this stream, so then everything will be come to this particular table. So only the deleted records, and then only update entries will come to the another table. So then, so once the details is available here, no need to maintain again the same details in the stream, right? So that's why, so the mechanism of the stream is always once it is consumed. Consumed means nothing but once you loaded the data from here to the so respective target tables. So for to maintain the historical things, so then so it will be flushed. Okay,
Okay, so
is it
a
clear now?
stream is, yeah, so a stream is equivalent to a stage table in a traditional data warehouse, right? And your source is
We can
source, your target is
consider
target, but stream is like
that.
your stage, but with specific intent
Exactly.
of insert, delete, and update. And you're not
Hmm.
waiting to go and delete it. As soon as you consume it as an insert or a delete or an update, immediately it will become clear. The data won't be
Yes,
saved at all. And while pulling also is going to pull what is specific, like insert means insert, delete means delete, update means ready for update.
exactly. That is true,
It's
Priya.
almost like an auto
That's okay.
cleansing, a stage
Exactly.
table with the auto
But
cleansing option. Okay.
in traditional things, what we have to do, everything, so we need to do it manually, right? So, but here, so no need to implement those things.
So in a traditional world, when we bring into staging itself, actually that will take a lot of time, right? Because you're
Exactly.
almost getting a copy of the source into the staging table. Um,
That is
but or based on update dates or insert dates or something we are going to bring, and even for delete we'll scan through the whole thing, so which is a lot of data. That's where most of the time is done. But here it is this going to get refreshed on an automatic basis? Like for example, right, in a traditional world, if I want to bring my data set
Mhm.
into the stage or even further down into a target, I'll be having
Mhm.
I'll be running a job, right? Like frequently, right? Like whatever the frequency is, I'll run and I'll bring the data. So in Snowflake, the stream insert, stream delete, stream update, the data, how is it getting captured? Is it an auto process or
But it's a
is it
auto process.
something that you
Yeah,
schedule?
it's a auto
It is all.
process. We are
It's
not going to
always an
schedule.
auto process. I never have to schedule for it.
No, no need to do any scheduling. Here also we observe the same thing, right? So whenever we have done any changes, automatically it is updating in a stream table. So we are not doing anything for this, right?
Okay,
It will be
okay. So
automatically it
that
will
is where
happen.
it's going to, performance is going to be really good because it's automatically keeping it ready for you. But target is based on schedule, right?
Based on schedule. That we can do that.
Okay, okay. But this one is automatically it's getting based on its logs.
Yes.
Okay. Thank you so much.
Thank you, Priya.
Sir,
So,
this is Raghunath. I have
yeah,
some
Raghunath, tell me.
questions regarding. Hello, sir. I have some
Yeah,
questions regarding the resume preparation. Should I ask now, or can we meet for half an hour?
we can connect offline. So after that, okay.
Okay.
Could you please inform to Soravi so he will give you the conference call. Okay.
Sure, sure. Yeah. Okay. Thank you.
I sent it already to you, so you can so check it and then let me know. Okay. So before that.
Sure, sir. Yeah.
Okay.
Sir,
Raghunath. Thank you.
hello.
Yes.
Sir, this is Balakrishna, sir. I
Yeah,
want to
Balji.
speak. Today I have joined this village call, sir.
Okay.
So I want to speak with you, sir, personally.
Fine, Balakrishna. So you can so connect with me after the session. Okay. So we will discuss.
Okay, sir.
Don't worry about
Okay.
that. Okay.
Okay, sir. Thank you, sir.
Thank you. Okay. Okay, just a minute. So we have a question here. So my question is how much time the data will be stored in a stream table? Okay. The stream table, it will be available if you don't consume. So it will be available 14 days.
I think how much data available means, I mean,
Mm.
is it 1 GB or 2 GB like that? I think.
How much data? There is no limit for that, Ishwan. So we can so keep so there is no limit for that. So because it's a cloud storage, right? That's
Yes,
why
yes.
we won't face any time like a traditional databases we will face when we are loading some data. We will face a table space issues, right? But
Yes,
here,
yes.
we never face the table space issues. Okay, there is no limit for the data storage.
Mhm.
Auto increment. Okay. Any other questions?
So I understand now
Mm.
with Snowflake, you have this option, right? Generally, I'm just curious. Let's say there's a staging table. There are sometimes even it'll take you like even 15 minutes to 30 minutes for a job to run, right? Like to just stage the
Mm.
table, right? After that, you can do your SED.
Yes.
Typically, let's say you have an Informatica or ODI and you're an
Mm.
Oracle database where your job takes you 15 or 20 minutes to get your data into your stage table. Here and then into your, let's say, another 5 minutes, right, from that part
Mhm.
to, or five, or
Mm.
let's say 10 minutes. Even 10 minutes is considered quite long for jobs, right? It takes 10
Correct.
minutes to write to your target. In a
Mhm.
typical scenario like that, how long does it take for Snowflake to work with this much amount of data? Let's say you have 5 million rows in
Mm.
a in
Mm.
your source table, right? And that's what you're trying
Mm.
to
Mm.
bring in.
Mm.
Typically,
Mm.
how long will it take in
I'll tell you something. So you have created your trial account, right, Priya? So if
yes,
you have
yes,
created,
yes.
just observe this in the Snowflake sample data. You can able to see my screen, right? In the
Mm-hmm.
Snowflake sample data, you can able to see some terabytes of the data here. So for the sample purpose, they have given. See this one, around 270 GB here, 1.7 terabyte of the data here we have, right? So just so if you file a query based on any specific, for example, any condition, based on any condition, it will not take more than 5 to 10 minutes. Okay, you can check that if you want. So here, okay, so on this table, you can file a query. So what will happen is basically everything, whatever we are doing here, right? Everything it will be created the table in a partitions. Let's assume that this particular data, so this to around 2 terabyte of the data, it is going to create around say 70,000 partitions. So we are going to discuss that in a partitions concept. Okay. So now what will happen is
Uh,
when it is
so
fetching,
you said you
let me
mentioned about
finish.
tera data, right? How many
Yes,
tera data you were saying? Sorry,
terabytes, 2 terabytes.
2 terabytes. Okay, that's okay. Okay,
Yeah, 2 terabytes of the data. 1 terabyte is 1000 GB, right?
yeah.
Okay. So when you have this data, so you can just fetch the queries from this. So by using the where condition, so that you can able to understand how much, so how fast it is. And at the same
Oh,
time,
great. Okay.
let's say, for example, every time when you are firing a query, just for example, I am giving, again, I will show you practically. So what it is, let me show you something if you have anything here. Insert it. When you get, this is very small things. Okay, so let me execute something here. Or let's take any small table. Catalog page. This is the column what we are taking, equal to 3. Okay. Now when I am executing this query, just observe. Okay. So how much time it has taken? 12.3 milliseconds, right? See this one, 12.3 milliseconds. You can able to see it here. And so how much data we have this year? Around 50,000 records, 2.7 MB. What will happen is in the back end, if you go and then if you check the query ID, and then if you come to the profile, so here it is only one partition. See this one generally. So here, so this is very small table, right? Here you can able to see number of partitions, total number of partitions. So if you have here, maybe you may have so 2000 partitions or 3000 partitions. But when it is fetching the data, the partition scanned, right? It won't go and then it will scan all the partitions. It will scan wherever the data is available. In which partition data available, those partitions only it will scan. So that's why it is very fast. It means let's assume that, for example, you have all the data it divided into 10,000 partitions. All these things will happen in the backend. So as a Snowflake user, we are not going to create partitions also. Automatically, Snowflake will create a partitions for the table. Let's assume in this particular case. So this so particular data. So these many partitions it's created. When you fetch any query, based on your conditions, it will pick only 10 partitions and it will display the data. Instead of scanning the complete table, it is going to scan only so 10 partitions only. So that's why so it is very fast. Okay, you can so check this once. So how the things will work in the backend. So anyway, we are going to discuss that.
Okay.
So in a partitions concept. So we'll so discuss clearly what it will be the how the will create a partitions in the backend. So what is the algorithm they will run. So, but as a user, as a Snowflake developer, so we won't have anything to do create like traditional databases. What we will do, we will create a partitions, we will create indexes. When you are loading the data, we will drop the indexes. Again, we will try to load the indexes, recreate the indexes. All this drama we will implement it to improve the performance, right? But here, so we no need to do all those things. So here, so automatically the Snowflake will take care of the partitions. Okay, any other questions? Okay, yes, thank you. See you tomorrow. Please practice.